Everyone, welcome to my YouTube channel. So today I'm solving Leetcode question 139, word break. Given a string S and a dictionary of strings word dictionary, return true if S can be segmented into a space-separated sequence of one or more dictionary words. Note that the same words in the dictionary may be reused multiple times in the segment. So let's say an example. For example 1, input S equals Leetcode. The dictionary contains word lead and code. So the output is true because this string S Leetcode can be separated into lead and code completely. For the example 2, this S is apple, pen, apple, and then the word dictionary is apple, pen. So in this case, we can segment this S into apple, pen, apple, return true. Because we are allowed to reuse a dictionary word, so in this case, we can reuse apple twice, at the very beginning, at the end. For the example 3, the string is cats and dog. So the word dictionary is cats, dog, sand, and cat. So unfortunately, we cannot break this one into the words. So you may see like many overlapping segments, but we cannot completely break down this string S into a dictionary words. So let's say we can try cats, but we but we don't have any words with OG, so that wouldn't work. So that break wouldn't work. We can try cat. So because we have a word cat in the dictionary, C-A-T, cat. And then the next word we can try sand because it's here, but we still don't have anything OG. So in that case, we cannot break this string S completely into the words in this dictionary. So that's why it's return false. Let's talk about how to solve this one. So basically, we are trying to break. So basically, the overall idea for solving it is actually dynamic programming. So why it is dynamic programming? Let's say try for each position. We want to see, okay, we're starting basically for this word, let's say lead, can we break down here? If we break down here, we can keep track of that. And the next time, when we encounter other words and then code, we know that, okay, we can already break down at from here. So that the overall idea is, let's say, for the string S, and then we try for each word. Let's say, okay, can it break down to the lead first? Okay, we find that, okay, the first 4 characters of this string is lead, and then we just mark here, let's say after this, to indicate, okay, we have already break down, find one word, and then we try the next word, let's say code. If the first several character can be break down into code, no, it cannot. Then we move on to the next position of the string. Let's say we try it here. So let's say if this string here can break down into a word, no. We try it here, no. And here, no. And then until we iterate through this position. Okay, so this is the last place we find last time when we can find, okay, all the positions before that can be break down, can be a word in the dictionary. So in that case, we're starting from here. Let's say, can we do that? Yes, we can. So that's kind of the overall idea for solving it. And then the overall time complexity is just going to be O, the length of S times the length of the word dictionary. Let me start coding. So we kind of have we kind of first get the length for the string, and then we have a list to keep track of all the breakdowns, all the possible breakdowns we have. So let's say at the very beginning, we say that it's all false. And then we assign, let's say we call dp0 equals true. And then we are trying to loop through S. And then we try it for every word in the word dictionary. Let's say in this case, when we basically we want to try, let's say if the I minus length W. If that is greater than or equal to 0, which means we are still within the boundary, and if we look at this string W I equals word. So what does this condition mean? It means, okay, for each W, let's say the i's the position I from the I minus W up until I minus 1. Remember, when we're trying to slice the string, we put I here, but it's actually go to the I minus 1 position. We indicate, okay, we can find a breakdown for this one. So basically, this segment of the string equals the word in the word dictionary. So in that case, we just update DPI. Let's say that's equals DPI minus length W. And then if we find, let's say, if we already find so what does this do? So let's say, okay, basically we can find a segment. So this segment equals the word. So it's a valid word segment. So if the previous segment, it can also be break down into some words in the dictionary. In that case, we got a valid breakdown up until the position I. But what if, like the previously, for all the previous words, we cannot break it down? So in that case, we don't have a valid breakdown up until the position I. So that's why this DPI value is depending on the previous position where the last breakdown end. And then after that, after we assign the DPI value, if the DPI value equals true, so in this case, we do not need to consider to try other W value from this word dictionary because we already find that a possible segment that is to make this DPI position equals true. Let's say, what if we continue loop? Okay, continue loop is, okay, let's continue loop. And then in that case, my next word, so let's say I have a word of length, let's say right now, this breakdown, the length of this word W that satisfy, that make this the current value of I, the DPI equal true is 3. And then let's say in the next word in the dictionary, we have the word of length 2, and then it still satisfies those constraints. However, if we are trying to do assign value, because if we go back to two prior positions, we cannot find a valid previous segmentation or previous breakdown. In that case, will be, if we don't have this break, we will override the DPI to false. So that's something we don't want to happen because previously we already find a valid breakdown that can successfully segment the word up until the position I minus 1. That's why we assign DPI equals true. And then after that, so we just return dpn. So basically, okay, if we can break down the entire segment and then up until every character, basically for the every character in the S, then we mark the end of the string S, the dpn, that will be true. So let's run the code. Cool, it's a pretty efficient solution. So let's go over this one through an example. So I prepared an example. So basically here, so if we look at the given example, Leetcode breakdown into lead and code. So for the previous iterations, let's say we assign, for example, the initialization dp0 equals true. And then for I equals range 1 plus 1 to n plus 1. And we just check for lead, in the word dictionary because it does not satisfy these constraints for the first several i's. So in that case, we just pass here. And then when I equals 4, and then 4 minus the length of lead, 4 minus 4, 0, greater than or equal to 0. And then the string from the position 0 up until the position 3, S03 equals the lead. So in that case, we find the segment. We just update the dp4 with the dp0. So dp4 equals dp0. So that's kind of the start of the string. So remember, we mark dp0 equals true. So in that case, the dp array looks like this. So we have a breakdown for the first 4 characters. And then after that, we continue loop. So because they are not satisfying this constraint, so we are not entering this if statement until we reach, let's say, when I equals 8, and then the word equals code. In that case, the dp8 equals dp4. So previously we find a breakdown, and then we assign the true value to dp4. And then so here we find another segment. In that case, we can do the update, and then we realize like, okay, it's the end. So it's actually dpn. So we successfully find a breakdown. So this is the end of video. If you like my YouTube channel, please don't forget to subscribe it. Thank you.